Hi, my name is Audrey Schroeder. This is my video presentation of ANOVA, Analysis of Variance. An analysis of variance, or ANOVA, is used to determine if there are any statistical significant differences between the means of three or more groups. So, if we want to analyze the spelling test scores for 3 first grade classes, we'd use ANOVA. Let's examine the variables in the spelling test scores for 3 first grade classes in our local elementary school. We'll use ANOVA because we have 3 groups: students in Miss A's class, Mr. B's class, and Mrs. C's class. All of the students are in first grade, and all of the students go to the same school. The one variable is the teacher, so we'll be using the simple ANOVA. If we chose to further divide the students, such as by gender, we'd use a more complex ANOVA factorial design. We'd then begin the 8 steps of computing an F-test statistic. The first step is to state the null and research hypotheses. In this instance, the null hypothesis is that there is no difference in spelling scores among the teachers. The research hypothesis is that there is a difference in spelling scores among the teachers. Following that, we'd set the level of risk associated with the null hypothesis. For this example, we will choose 0.05. Next, we figure the variance within the groups and between the groups. The F-test is arrived at by dividing the variance between groups by the variance within the groups. The larger the ratio, the more likely it is the groups have different means. In a 2015 article, Optimization of Solvent Extraction of Shea Butter Using Response Surface Methodology and its Characterization, used ANOVA to analyze variances in extracting shea butter from shea nuts using a chemical N-hexane versus traditional methods. Variables considered in the study were sample weight, solvent volume, and extraction time. The study sought to find a way to optimize the extraction of shea butter from shea nuts. Traditional means were too cumbersome and tedious. The 5 steps were thermal treatment of the seeds, grinding, extraction by boiling, oil recovery, and drying. The act of extraction caused damage to the components of the nuts, resulting in a degradation of flavor and aroma. As the scatter plot and Table 1 show, with chemical extraction, the optimal yield efficiency of the shea butter was 66.90% in 40 minutes. Traditional means had a yield percentage of 28%. The ANOVA showed a significant effect in the yield percentage of shea butter with an R-squared factor of 0.8989. In this real-world application, ANOVA helped to reveal the optimal yield of shea butter from kernels in 40 minutes is 30.4 grams. This concludes my video presentation of Analysis of Variance, ANOVA. Thank you.